class session, that is the yesterday's class session. So first is the regular expression that are a way of specifying the text processing condition. So if I want to specify any condition, that may be in the C language, that may be in the C++ language, that is specified with the help of the regular expressions. We have studied about the expressions in the C and C also, that is used for the representation of the various algorithm that is defined in the C and the C++. Now in this chapter it is going to use in the cold fusion, that is a CFML, that is a cold fusion markup language. That is a language that is used for the cold fusion, that is a part of the Perl 5. So there are basically two ways, or the two basic ways by which we can use the regular expressions. Now what are the two ways? The first is searching for the symbol pattern. So we are searching for the symbol pattern that is defined in this one. The next is replacing. So one is used for the searching, one is used for the replacing. Searching means to find out what are the various conditions that is explained in this one, or what are the various scenarios that is used in this one. There are the various regular expressions that is processing the conditions. So to process the conditions, we use the regular expressions for giving the conditions in a specified manner. That is known as a regular expression, that is known as a text processing conditions, and it is used in a number of programming languages. That may be HTML, that may be a cold fusion, that may be a Perl. It may be used in any languages, any programming languages, any scripting languages that is used, that is known as the, or that is done by the regular expressions and the string processing. Then whatever the cold fusion, whenever the cold fusion we are using, that is used for the two concepts, that is the searching and the replacing. So we can search anything, we can replace anything. That is done by replacing and searching the content. So search for the symbol pattern. So search for the conditions, that is used for the searching and the replacing. So there are four REs. There are four regular expression function that is used in the CFMX. One is the RE-find, that is used to find out the RE string from the starting point, then return the substring, then RE-find no case, then RE-replace, then RE-replace no case. So these are the various cases by which we can use the replace string, REGX, then there is a sun string, then there is a scope, then there is a replace, that is a RE-place no case. So there is a no case that is available, that is also done by the string REGX, then substring scope. And the first two functions are used for the searching, that is used for identical, with the exception that in the first case is a case sensitive and other is a case insensitive. So one is a case sensitive, one is a case insensitive. That is a function that is used for defining the regular expressions, and these functions can take up to the 4 arguments, and out of which two first are the required. So there are two arguments that is required for the main string, that is REGX, then there is a string, and the first required argument is the regular expression that containing the condition for identifying a simple pattern. So whenever we are using the simple pattern, that is used with the regular expression, that is used in the text string, that is given as the second requirement argument, that is the RE-find, then RE-find no case, RE-find replace, then RE-replace no case. Similarly, for the third and the fourth functions used for the replacing, that is the third and the fourth function is used for the replacing the content, that is used with the regular expressions, right? Next, the syntax that is used for the formal or forming the regular expressions is based on the sets of the operators. So that is used for increasing the set of the operators. Larry, are you able to hear me right now? Is it audible to you? Hello? Okay, Larry. So that is used for setting up the function, that is used for syntacting the function, that is used is available in the proper operator, then character classes, and or the portable operating system interface, that is the POSIX classes. So there are various classes that is based on the sets of the operators, character class, portable system class that is used. And for a more detailed description of the syntax for regular expression, consult the RBB. So there is a consultation of the RBB that is used for the regular expressions. The next is revisiting the search engine, that is how to revisit the search engine that is used to verify the content. So in session 6 we studied how to build a search engine by means of the verity module included in the cold fusion. So whatever the cold fusion that is used to revisit the search engine, and one of the verity function that was included was the indexing, that is used to explain the contents of this function, that is a verity function, and that is done by the parsing. So one of the indexing function that is used, that is known as the parsing. that is identifying and marking. That is identify and mark the collections indexing function that process each document by the parsing. So whatever the document that we are referring, that is referred by means of the parsing, that means by means of the content, that is identifying and marking each word of the document. For building a frequency list containing each different word appearing in the document. So whatever the word that is appeared in the document, that is appearing in the document. And when the parsing of all the documents is completed, a frequency or word frequency list for the whole collection has been generating. So when the parsing is completed, then the whole collection has been generated, that is the frequency list has been generated. And for each recorded word, links have been established to all the documents in which the words count. So whatever the word count that is available for the word count. This is the more text, then there is a yes, read a text, read a word, then there is a new word, then end of this, file. That is the insert operation, new operation, yes operation, no operation, that is available for the logical diagram for the indexing. And the result will be an inverted index of the word. That means first of all read a text, then read a word, then there is a new word, then there is the end of the file. Text that is available for this one, that is used for reading out the text, that is used for reading out the text, that is used for reading out the text, that is used for inserting the text, that is available in searching the content. So that is a read a text, read a word, a new word, that is also going, that is a read a text, then read a word, then there is a new word, then end of the file, then more text, yes, then there is an insert that is carried out, then there is a yes or no, then there is a update. So this is the result that is available is an inverted index that is used for available documents. And document that containing the requested words can then easily be localized by means of the index. So whatever the index that is generated by means of the index, and based on the each word total frequency in the collection and its local frequency in a document, different kinds of scores of relevance for the individual document can be computed. So different kinds of scores of the relevance. So whatever the score that is available for the relevance that is used for the individual document, that can be computed in a similar manner as we do in the document, that can be localized by means of the index. In the following example, we demonstrate how to construct a template which reads a text file. That means how what is a template, that is how to read a text file, passes the text by means of a regular expression, and build an object. So that is how to build an inverted word object for the document. So that is used to build an inverted word object, that is used to demonstrate how to read the file, how to parse the text by means of the suitable documents. And to make the demonstration complete, the application has an introductory form by means of which you can upload your text file. That means first of all read the file, then parses the file, then build the file. So there are multiple steps that is used for this one. First is used for the parsing, reading the file, then parsing the text by means of the regular expressions, then build an inverted word index for the document. And to make the demonstration complete, the application has an introductory form by means of which you can upload your own text file. That is uploading the text file, that is also available in this one. And the second template, that is a parcel.cfm, that uploads, parses and print the results from the specified file. That is used to specify the file, that is used with the parcel.cfm. Now first one is the index.cfm, that is an introductory, that is a index file will be maintained, that is a cold fusion markup, that is the index.cfm. There's a h3 tag, that is a heading number 3, then font color equals to blue, then it is available in the blue color, that is a text file formatting or indexing. Then the font will be closed, h3 will be closed. Then cf form, that means the form tag is used in this one, that our action equals to parcel.cfm and method equals to post. That is the action is given as a parcel.cfm and method is given as a post. Then next is given as the name of the file, that is given as a text, that is given as a type as a file. So this is a file that is created, then the name is file name. Then input type equals to submit. So next is the submit button that is created, and the value that is available is the submit. Then the cf form, that is the form will be closed over here. This is the opening of the cf form, this is the closing of the cf form. And the purpose of this template is to permit the user to specify a text file at the client computer for uploading to the server for processing. So whatever the server, whatever the content that is available, that is used to specify a text file at the client computer, so that the content will be uploaded to the server for processing. The next step is to search sequentially to the text string into the file to identify each separate word. So that is used in the sequentially, that is used to identify the each separate word. Record the identified word in a list if it does not exist already, or increment the frequency counter if it exists. So that is used to search the content, identify the content, record the identified word, then increment frequency counter, and repeat for the next word. So these are the various steps that is used for the content file, that is used for contenting the file. And for each existing word, its frequency counter is incremented by 1. So whenever there is an existing word that is available, so its frequency counter is incremented by 1. And when the document is exhausted, the words are sorted in a descending order with the most frequent on the top of the list. So when the document is exhausted, and when it is full, then the words are stored in the descending order with the most frequent on the top of the list. That the priority is given on the top of the list. Where we are. No, 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 no. The next step is to identify this one we have given. So the purpose of the template is to permit the user to specify the client machine, that is used in this one. And in the following template, that is a parcel.cfm, line 2 or 3, that specifies the file you use in the line, this one and this one. So let's start with this first of all, that is a parcel.cfm. Then there is again the cf file. So file will be used with this one, that our action, and there is a file field that is used in this one. CF file, then action equals to upload, then file field equals to file up, then destination equals to path, then file up dot txt. So file action equals to given as upload, then the file field that is given as a file up, then the destination, that is a destination account that is available as a hash path hash file up dot txt. Then the name conflict that is given as a override. So file have a action, file have a file field, file have a destination that is available, and file have a name conflict that is a override. Then there is a CF file, then action equals to read, then file equals to hash path hash file up dot txt, then variable equals to file up. That means the action is given as a read, then file is given as a path file up dot txt, and the variable is given as a file up. That is a CF file action, then CF file action equals to read. Then CF set. Now setting the document size equals to length file up. So there is a length that is available with the file up that is used with the hash. So that is the document size is given as a length of the file up. So whatever the file up document that is given with the length function. Then CF set, then start equals to 1. So start is, or the value of the start is equals to the 1. Then CF set, then frequency underscore structure equal to struct new function. So that is a frequency structure that is available, that is used to define the struct new function. Then CF set characters process. So whatever the character that is processed equal to 0. That means the CF set, that is a character that is processed, that is equals to the 0. Now giving the character process, that is equals to 0. Then CF loop, condition equals to a number of characters processed hash, then lt, then document size. That means whatever the character process that is available with the lt is a variable that is defined over here, then there is a document size, that is a hash size. Then CF set position equals to ref, that is a regular expression find no case. Now it is using the no case, that means there is no considering of the case, that may be uppercase, that may be a lower case. Then there is a punct, that is a punctual, then there is a punctuation mark, then there is a space, then the file up start. That means the file up is used from the starting point, so there is no case that is considered over here. Then CF set, then word equals to mid. So whatever the word that is given, that is the mid, then file up, then the start, then position, then start. So the file up event will be used that have a start condition, that have a position, that have a start. Then CF set hit equals to 0. Hit is available, so set the value of the hit equals to 0. Set the value of the counter equals to 0. So set the value of hit equals to 0 first of all, then set the value of counter equals to 0. Then CF loop, then condition equals to hash counter LT struct count frequency structure, then and hit equals to 0. That means the condition is if the counter that is that of LT, then that have a structure count, that have a struct count, that is a frequency structure, and the hit equals to 0. Then CF if struct key exists, so whatever the key that is available, so that exists. So if the struct key is exist, then the frequency structure is used for the wording the word. Then frequency equals to struct find, that is the structure is finding over here, then the frequency structure, then word. Then CF set, then struct insert, that is the struct insert will be used, then frequency structure, then word, then frequency, then +1, then true. That is the frequency structure is used for the word, then frequency +1, then true. Now it is giving the hit as a 1. So this is the scenario when the hit is equals to 0. That means the hit is missed. So this is the scenario that is used. When the hit is 1, that is CF set hit equals to 1, then the loop will be closed. That means it will only be activated when the hit is equals to 0. Otherwise it is closing down, it is running down. That is the CF if will be closed over here. Then the CF set, then counter equals to, now setting the counter equals to counter +1. That means I incremented the counter by 1. Then the CF loop will be closed. So that is the CF set, then counter is given as counter +1, then the CF loop will be closed. Then there is the CF if, now there is a hit that is equals to the 0. So that is hitting the value that is equals to the 0. Then CF set, that the struct int frequency structure word 1. That means the frequency structure has a word that is equals to the 1. Then the CF if will be closed over here. Now again there is a CF set, then start equals to position +1. That is the position is available, that is available with the +1. Then the character processed, then character processed plus length word +1. That means whatever the character process, that is equals to the length of the word +1. That means it is always incremented by 1 or giving the value that is additional with the 1. Then the loop will be closed over here. So that means the loop will be closed over here. Then div, that is the division, then align equals to center. That is alignment is given as the center, then there is a h2, then font color equals to blue. That means the font color that is available as a blue. Then word frequency list, so there is a word frequency list, that is a div align equals to center word frequency list. Then the font will be closed, h2 will be closed, div will be closed. So that is the align equals to center. That means we are creating the division, or we are creating a table, that is align equals to center. Then there is a h2 tag. That means there is a h2. Then there is a font color equals to blue. So font color is given as a blue. Then the word frequency list, then the font will be closed, h2 will be closed, and div will be closed. Then table align equals to center. So we are giving the table that is the alignment equals to center, then border equals to 1. So we are giving the alignment that is equals to the center, then the border is giving as a 1. So align equals to center, then the border equals to 1. Then there is the tr tag, that is the table row. Then there is the table header, that is the word. Then there is the th, then there is the ta, then there is the frequency. So there is the th, then there is the word, then there is the ta, there is the frequency. then CF set, then my list equals to array to list, that is available with the array to list, then struct sort, then frequency structure numeric descending. So whatever the structure that is available with the struct sort, that is considered for the frequency structure, and that is of the numeric, and there is a descending part. Then CF loop, then index equals to word, then list equals to my list. So whatever the my list content that is available, that is used with the my list. And then the CF output will be open. Now there is a display for the CF output. So whatever the output that is available on the computer screen, that is used with the CF output. Then within the CF output there is a TR, that is a table row, there is a TD. Within the TD there is a word, then the TD will be closed. Another TD, that is a struct find, that is a frequency struct word, then hash, then there is a TD that is closed over here, then the TR will be closed. So this is the opening of the TR, this is the closing of the TR. Then the CF output will be closed, then CF loop will be closed, then table will be closed. So the last part of this template, that is from the line 27 to 39, this is the last part, that is from the div. This is used for outputting the value, that is an ordinary tabulation of the list. So that is the ordinary tabulation that is available with the list, that is a word frequency table. These are the various expressions that is used with the frequency table. So the most frequent words that is used in the extracted list. So that is used for ordinary tabulation of the list. And line number 31 orders the word frequency list in frequency descending order. While line number 35, that is this line, that is prepare the words and its implementation of frequency for display in the table row. So whatever the display that is available, that is display in that available row, that is used for the table data. And the CF loop will be closed and the table will be closed over here. And these are the various cases, or these are the various theory that is used with this one, that is used with the delimiter, then the pass.cfm, that is the CF loop will be used over here. So the core of the process is surrounded by two pairs of the CF loop tags, that is used with the CF loop tags, one nested in the other, and both functions are used as a while loop. And the first, that is starting at the line number 8 and closing at line number 26, is traversed as many times as the process identified. So whatever the words that is identified, as many as time as the process identifies the words. And the second and closing line, that is line 13 to 20, is traversed for each character in the core of the parsing process starts by finding each word, that is done, or this is done by the line number 9, in which the position of the end delimiter is identified. This is line number 9, in which the position of the case will be used, that is a punctuation mark, space bar, that is used with the file up and the start. That is defined by the RE, that is a regular expression find no case, in which the criteria for finding the next word delimiter is a regular expression that is appearing in the first argument. So whatever the first argument that is available, that is appearing for the first argument, that is used for finding the delimiter, that is used for finding the delimiter, that is used in the POSIX classes, that is a punctuation and the space that is data used. Note that in the function, the square bracket must be repeated to be correctly interpreted. So whatever the square bracket or wherever the square bracket will be used, that must be repeated to be correctly interpreted. And the first class matches most punctuation characters not appearing as a part of the English word. So whatever the English character, whatever the English word that is used with the punctuation marks as well as the space bars. And the second class matches the spaces. So first class match the punctuation mark, then second class matches the spaces. And as indicated above, the same result could also be obtained by a regular expression that is based on the character classes. So whatever the character classes that is used, so that is used with the same result that can be obtained by a regular expression that is based on the character classes. So one is the punctuation marks, one is the space bar. And with the position of the end of the or at the end of the word, the start position of the word, that is three arguments needed for the string function, that is a MID function. So there is a MID function that is used for string, that is used in the line number 10, that extracts the word that is available, that extracted the word that are available in the MID function. And line 11 to 21 determines, so there's a 11 to 20 lines, for example, these are the 11 to 20 lines that determines if the current word already exists in the frequency list, that is from 11 to 20, that is from this one to this one. So if there is a hit, that is equals to 1, hit equals to 0, that is available. That check for the condition if the struct queue already exists or not. And if the word has already been recorded, the frequency number is incremented in the line number 16. And if not, line number 25, insert the words and the next word is extracted and tested against the list of the words. So whatever the words that is available, that is used to list the word, that is used to list the content, that is used for the extracting the values. So this is one part, that is display the short text. This is the word frequency list. There is a word frequency. These are the various expressions that have a frequency 5, regular 5, parallel 5. Now next is the implementation, that is how to implement the contents that is used in this one. I'm just coming within 2 minutes. So the next part that is available, that is after that is coming, that is known as implementation, that is how to implement the concepts that is used within this one. So that is the implementation, that is implementing the concepts, so that is how to implement or how to use in the application, that is implementing the concepts, right? So that is the implementation. The application that has been implemented as an example and is available by the link, that is available with the link at the end of this session. So the application that have been implemented as an example, so whatever the example that is implemented, whatever the scenario that is implemented, that is available by the link of the end of this session. Observe that your file used in this example should be a text file .txt file, and that's the absolute address to the file. So whatever the absolute address that is available, that is used as the absolute address at the end of this session to the file on your computer, that must be specified. And you can try the files with the other extensions also, but the main concern is that you can use these files with the .txt extension, that is text file extensions. And but you can also try these files with other extensions, but the results may be affected by the formatting code of the particular code, the file help. So whatever the file help that is available, that is of the particular file help or file type, and the create the problem. Now if you, for example, parse a.html file containing a number of p tags, so there are multiple p tags that is used with this one, so that the p's are surrounded by the symbols, that is a tag that is used with the various symbols, that is the opening of the p, then there is a closing of the p. So the p's are enclosed within a tag, that is a left angle bracket and the right angle bracket, which are considered word parameters. So there is a word parameter that is available with the p tag. Consequently, the word p, that is p means the paragraph tag that appears with the high frequency. That means we are using the p tag multiple times. So there is a p tag, that is a paragraph tag. The best way to try out the parcel is to use a document in Notepad. So the best way that is used to try out the parcel, that is used to prepare or use a document in the Notepad or another ASCII text processor. In a real world scenario, in a real application, the frequent words such as the and, or, but, the, and the words such as the pronouns I, you, she are specified in the list, that is a stop word list used to exclude these words from the word frequency list. So whatever the frequency list that is available, that is used to denote the words such as the and, or, but, the. So these are the various words that is used in the frequent words, such as the pronouns, or that is used I, you, she, that are specified in a list, that is list that is known as the stop word list, that is used to exclude these words from the table, that is used to exclude the word that is available within the table, right? And in the real application, the formatting specification should also be eliminated from the text. So whatever the text that is eliminated, so there is a specification that is used to eliminate from the text that is before the used before the indexing, right? So that is implemented using the ASCII text character. Now uh, my question is to Joseph. Joseph, can you tell me the full form of ASCII? Joseph, can you tell me the full form of ASCII? Now the question goes to the Larry because there is no reply coming from the Joseph. I think he is not available. So, Larry, can you tell me what is the full form of ASCII? Larry, are you able to hear me? What is the full form of ASCII? Very good, Joseph. That is the American Standard Code for Information Interchange. That is the ASCII codes in which there are multiple characters, there are multiple number that is given as a number value. So A has a value 68, 90, for example, and the small character have a different value and the big character have a different value. So in a real application, the formatting specifications should also be eliminated from the text before inserting. Before inserting, it is used for inserting the values, that is used to eliminate from the text before the indexing values, right? Now, there is the next language, that is CFScript language. So the introduction of the CFScript language, that is what is the CFScript language that is available in this one. So in the introductory session of this course, it is pointed out that the Cold Fusion, that is the CFScript language, is based on the tag-oriented language that is known as the CFML. So there is a Cold Fusion language that is pointed out in the Cold Fusion that is based on the tag, that is based on the tag-oriented language, that is and what is the name of the tag-oriented language? That is the CFML, that is the Cold Fusion markup language. There is a Cold Fusion that is used with the CFML, so that is a tag-oriented language. However, but CFML also includes a scripting language. So CFMX also includes a scripting language which can be activated by the tag, that is a tag is known as the CFScript. So there is a tag that is available that is known as the CFScript, and this language has syntax similar to the ordinary programming languages such as the C. Everything is same in the CS scripting language. Every syntax is same, that our syntax that is similar to the ordinary programming languages such as the C. It has syntactically also many similarities with the JavaScript. So that means syntactically it is also very similar with the JavaScript, and we shall return to the JavaScript in the next session. That means we shall return to the next, in the next session we are going to study about the JavaScript. While the JavaScript is a tool for extending the HTML on the client side, the scripting tool CFScript is an extension of CFMX on the server side. So there is a server side scripting, there is a CF scripting that is used for scripting values, that is a CFMX that is used to develop the values in the CFMX contents. And the syntax of CFScript is very simple and discussed by the RBB in chapter number 9 of this book. You should also note the basic rules. So these are the various basic rules of the CFScript. So CFML and the CF script. So there are two parts. Now what is the main difference between the CFML and the CF script? In the CFML, that is just treated like a programming language, or this is a program that is a programming language. In this the programs in the CFML, there are programs that is running for the CFML, and within the CFMX, that is a scripting language. In this we are using the tags. In this we are using the script for writing the messages. So the syntax of the CFMX is it's simple and discussed in this one, and this is also the take care of the syntax value basic rule of the CF script. So CF scripts can be included in the CFMXL or CFMX templates. So CFMX scripts or the CF scripts are included in the CFMX templates, but must always be enclosed by the tag pair CF script and the closing of the CF script. So there is an opening of the CF script and there is a closing of the CF script that is available within the CF script that can be included in the CFMX templates. Second point, CF tags cannot be used within a CF script. So we cannot use the CFML tags that is used within the CF script. So in this there are multiple tags, there are multiple parts that is enclosed within the CF opening CF script and the closing CF script. Then CF functions can be used in the CF script. So whatever the function that is used, that is available in the CF scripts. And the variable that is defined in the CF templates are available in the CF script and vice versa. So whatever the variable that is defined in the CF template that are also available in the CF script. CF scripts usually give more compact code than CFML, and many programmers trained in conventional programming feels more comfortable with the CF script than with the tag-based statement of the CFML. So CF script is more higher in demand as compared to the CFML because most of us we are preferring the tag-based scenario as compared to the programming languages as compared to the code fusion markup languages. Now there is a difference. There is a comparison of the CFML and the CF script. So to demonstrate the CF scripts, we are returning to the parcel.cfm templates of the regular expression example that is discussed in the first part of this session. So one of the example that we are discussing this part in this session, that is a parcel.cfm, that is using the regular expressions for coding the first part of or coding the parcel.cfm. And whatever the code that is used for the parsing is now developed by means of the CF script. So the code that is the parcel.cfm is now used or now developed by means of the CF script instead of the CFML tags. CF file that is a CF file tags that is in the beginning of the parcel template of the previous section. So whatever the CF file tag that is used for the uploading and handling the file that it will be passed, and the final table tags are used for displaying the result that are kept unchanged in the example of this session. So whatever the session that is available, that is keep unchanged in this example of this session, that is a parcel script.cfm, while the tags for processing and preparing the word frequency list are substituted with the CF script code. So whatever the script code, whatever the scripting that is used with the CF script code. That is comparing the CFML and the CF script. So the parcel script.cfm template start with the CF file. This is the main comparison that is used in this one. So first one is the parcel.script CFM that template start with the CF file tags that need to be uploaded to the location, that is a path file.txt. So there is a path file.txt that is used to read the text file. So that is a CF file tag that is used to reading the file, that is a parcel.script or parcel script.cfm. Then follows the CF script block. So first is there is a CF file, that is a parcel script.cfm. Then there is a CF script block and the template ends with the CF output tag block. So whatever the tag block that is used with the CF output. The value, that is the hash path hash, must be set compatible with the web page organization of your server. So whatever the server, whatever the scenario, whatever the organization that is using, that is the value, that is the hash path hash, that must be set compatible with the web page organization of your server. That is a parcel script.cfm. Note that like many other languages syntaxes, the syntax of the CF script requires that each statement is terminated with the semicolon, and as mentioned, CF scripts permit the use of all CFMX functions and the variables. So whatever the function that is available, whatever the scenario that is used with the CFMX functions and the variable. Almost a one-to-one corresponds between the tags of the previous example and this one. So there is a one-to-one tag that is used with the scripting language, that is a parcel.cfm. Now next is this is the parcel script.cfm. This is one of the coding. This is one of the best coding of this example. And in this is also very important, that is there is a one-to-one correspondence that is used between the tags of the previous example and the scripting statement that is can be obtained. And because of the strong similarity between the two templates, what are the two templates? That is the parcelscript.cfm as well as the CFML, that is the parcelscript.cfml, and the parcelscript.cfx, that can be easily interpreted and understood without any further explanation. And however, with the use of special CFScript function, that is a write output string appearing in the lines 9 and there is a special function that is used with this one. It writes the text to the output stream. So parcelscript.cfm. Now let's see what is the parcelscript.cfm. There is a CF file, that is the action equals to upload. Now action is given as a file, or action is given on a file, that is the action. What is the action that is given is the upload action, right? Then there is a file field. What is a file field? So what is a file that is available in this one? That is a file up is a field. Then there is a name conflict. That is a name conflict is the override. So whatever the override condition that is used with the override. Then there is a destination that is equals to the path file2.txt. That is a destination that is available with the file2.txt. That is a next of the file.txt that is available with this one. Then there is a CF file, then action equals to read. So one is the action, that is the upload action. Then the next action that is available is a read action, and the file that is available is the hash path hash file2.txt. Now next file name is the file2.txt, and the variable that is used is the file up. So the variable name that is available is the file up. Then cf set document underscore size equals to length of the file up. So that is a number of the length, or we can say counting the number of the length, that is the file up. So whatever the scenario that is available, so what is the content that is available within the file up, that is the length of the file up. Then there's a CF script. What is a CF script? Says that start equals to 1. So starts with the 1. Then frequency structure equals to struct new though. What's the frequency structure that is available? That is a struct new. Then character processed equals to 0. That means character processed equals to 0 means the character processing will be start with the 0. It is initialized with the 0, like the same variable that we have discussed in the C and the C++, like sum is equals to 0. In the same way, characters processed equals to 0. Then next is the write output. That is the write output that is available with this one. That is the write output that is used for writing on the screen. So this is available, that is the write output string that appearing in the lines. It writes the text to the output stream. So whenever I want to write on the output stream, that is displayed within the write output. That is the text file up br. That means first of all the text, whatever the text file that is available within the file up, that is displayed, and there is a line break, that is a br tag. Then write output document size, that is document size, then characters, that is the document size is the number of document size and the number of characters that is available, and again there is a br tag, that is a line break tag. Then the while hash characters underscore processed hash, that means while the number of character processed is number 8, then the document size, so number of character processed is the number of document size that is available. Then position equals to re find no case, that is the position is available as a re find no case, and punctuation space file up start. So whatever the start function, whatever the function that is available, that is used with this one, that is the regular expression is used for finding the values without any considering any case, that is punctuation or not the space. Then the file up start. Then what is the word? Now taking the word as a mid of the file up start. Then the position start. So the position will be used as a start function. Then the mid characters will be used or can be taken for the file up. Then there is the start, then position, then start. Then hit equals to 0, counter equals to 0. So hit is given as a 0 and the counter is given as a 0. That means initializing the variable of the hit equals to 0, then counter equals to 0. Then the while loop will be used. Now while the number of counters, or while the number of counter number lt, that is a less than struct count. So if the number of counters that is less than the struct count frequency structure and hit is equals to 0. So if the is less than the frequency structure and the hit is equals to 0, then if struct key exists, so if there is a struct key that exists, so frequency structure word, that is a hash word hash, so there is a struct key exists, so that there is a frequency structure that is available, Then frequency equals to struct find. So that is a frequency that is used as a struct find. Then frequency structure, that hash word hash, there is a frequency structure that is available. Then there is a struct find, that is a frequency structure word. Then struct int, that is a struct inside, that means the structure will be inserted over here. Then frequency structure, then word, then frequency plus 1, then true. Now that is the true value will also be arrived. So it check the condition. If the counter is less than the struct count, that is the number of the count, and there is a hit that is equals to the 0, then hit equals to 1. Now the counter is incremented by 1. So whenever the hit is 1, that is whenever there is a hit, so the counter is incremented by 1. Then if the number of hit is equals to 0, that is a hit is now equals to 0, then struct insert frequency structure word 1. That means the frequency structure will be used and word have a value 1. Then start equals to hash position hash plus 1. That is the position tag will be used with this one. That is the hash position hash plus 1. Then characters process, then plus len word plus 1. So that is the length that is used as a word, that is the len word plus 1. Then there is a CFScript, that is the closing of the CFScript. Then there is a CF output, that means the output will be available with this one. Now this is the TID, there is a TID 2, that is for the time format, that is a now. Then there is a HHMMSS. So there is a HHMMSS. So that is the hours, minutes and the seconds, and the CF output will be closed. So that means the first is the CF output, then there is a TID2, that is for the time format, and there is a CF output closing, that is the closing of the CF output. Then there is a DIV, that is a division tag will be used, then align equals to center, then H2, then font color equals to blue, then there is a word frequency list and the font will be closed, H2 will be closed, DIV will be closed. So first of all there is a font that is closed, this is a font, then there is a H2, that is H2 will be closed, then there is a DIV will be closed. Now this is using as a table. Now aligning the table, aligning the whole table in the center, then border equals to 1, that means align the whole table content into the center and giving the border as a 1. Then there is a TR tag, then there is a TH tag. So there is a table row tag, there is a TH, that is a table heading tag, then word, that is a TH, then TH frequency, that means in the one header this is a word, then another header that is a frequency. So in the one row this is the word, then another row that is a frequency, then the TR will be closed. So this is the opening of the TR, this is the closing of the TR. Then CF set, then my list equals to array to list struct stored frequency structure numeric descending. That is the array to list will be used, that is the struct sort function will be available, then the frequency structure, then numeric, then descending, then CF loop, that means the CF loop will be used, then index equals to 1. So looping will be continue with this one, that is a CF loop, then the index equals to word, then list equals to my list. So list is available as a my list. Then the CF output, that is the CF output will be used over here. Then TR, then TD, then the word, then TD will be closed, then TD, then struct find, that is the frequency structured word, then hash, then TD, then TR. That is the TR, TD that will be used for creating the word row and the data. Then there is the closing of the CF output. This is the output tag, that is the CF output. There is a one row, there is a two rows that is used in this one, and there is a header, that is a CF output. Then there is a closing of the CF loop. Then the table will be closed over here. So this is the table that is starting with this one, and this is the closing of the table. So there is the table that align equals to center, then TR, TH, TR, then my list equals to array, then index equals to word, CF output in the same way, this one, this one, this one. That means this is useful, this one. For the example of this session, the code was implemented with the same index.cfm. So there is an index.cfm so that it will be implemented, or the code was implemented. Now, what is this example? That is example that shows how the scripting will be used, how the tagging will be used, how the different tags will be used in this one. So that is the code was implemented with the same index.cfm that template as in the previous example containing the form that is required for specifying for identifying the text file to be uploaded. So whatever the text file that is uploaded, that is used for the same text file. The example can be tested by using the link at the end of this session. So whatever the example that can be tested by the using of the link or by using the link at the end of this session. And if used at the same text file as you used for the example of the previous session, the result shall be identical. So whatever the result that should be used, that the result should be identical with the linking of the end of the. Now, what are the advantages of the CFScript over the CFML? The advantage of the CFScript will become significant in more complex processing tasks. It seems to be a trend that scripting is used for developing the user-defined functions. So scripting is used for the user-defined functions, and there is a CF component that is designed for the intensive reuse. So CFScript will be used for the user-defined functions, and the CFML is used for the reusing again and again the same coding, same variable. Now, what is the conclusion? Conclusion is that main objective of the cold fusion that is used is the RAD, that is a rapid application development tool, and this is CFScript is more compact, elegant, and the efficient code, and the price to be paid for may however be less than the rapid development, and the optimum development that is carried out within the application task, and the development preferences, knowledge, and experience with the CFML tags and the scripting. So whatever the CFML tags, whatever the scripting that is available, that is used for the optimum development, that is used for the optimum development strategies, that is a part of this one, and the price paid for using the CFScript that may however be less than the rapid application development. So one of the main target that is used for the cold fusion is the rapid application development, that is a RAD. Now this is the exercise for you. Then session number 12, that is a tomorrow's session, that is a session number 12, that is a reusing the code, that is how to reuse the codes. So let's stop over here only. In the tomorrow's class I am taking your next session, that is session number 12. So thanks a lot everyone. Any doubts, you can ask the doubts from me. So thanks a lot everyone. Bye bye. Yes, Joseph, hello, how are you? Yes, Joseph, tell me. Yes, tell me, Joseph. Yes. Okay. That is a procedural programming. You want the assignment, you want can I open the assignment for you? Just a minute. For C language. Okay, just okay, just a minute. This one. Yes, tell me. Yes, you have to design the user interface, implement a code. For example, this is the example that is given. This is a scenario. You have to design the coding for this one. For example, if the software there is a cheese and the tomato, the rate is 3.50. So you have to apply the coding part, if loop, while loop, as per your requirement. And that may be any. That may be a console interface. That may be a Windows interface. Your assessment marks. You have submitted all the assignments. No, no, no. The main thing is that, Joseph, listen carefully. We have to compile all the grades by compiling all the assignments, because now 15th of Feb there is an inspection in our institute for this Edexcel course, that is used for the assessment criteria, that is used for the assignment, whether the assignments are going well in due course or not. So that is the main concern, and for this one, we have to consider for the each and every grade that is compiled after getting all the assignment. That's why I asked yesterday that whether given for the object oriented or not, because in mine it is clear that I have given already, but that is my fault. So I have given yesterday only. So after compiling all these concept, all these assignment, I have to give you the grades. So how much assignment you have left with? So complete by this weekend, because in the next weekend there is a inspection in our institute, so that impact your grade, that impact your assignment. So please submit, hurry up. And my question is to Larry, what you need with the Rakesh? Any specific that you can told to me? Larry, are you able to hear me? Any criteria, any content, any confusion, any knowledge that you gain from the Rakesh? Can you tell from me? Hello, Larry, are you able to hear me? All right, there is no contact with the Larry, because Larry has given me a message that the Rakesh had left the organization. That is, Richard has left the organization. So, to whom you are contacted? You are contacted with me. So, yes. Hmm. Okay, that's why I'm asking from you, is there any concern regarding the class, regarding the assignment, regarding which thing do you want to concern with? Regarding the fees, regarding what thing?